I'll leave our speakers to add something that they consider important for the audience, and then we'll start with the questions.
Yeah, thank you very much for this very kind introduction. You're very polite. I can say I know something, but the more I learn, the more I see more problems. So there is always a next question after you answered one. So by the time you feel like you don't know much, which is a big problem, but on the other hand, still you can answer a lot of things. So the truth is, every day I got to know something new. And I've learned something already today, here, from you people, and like in the observatory over there. And thank you very much for this. So every day should be a new day, and we try to find out. And we don't know what we will use our knowledge for tomorrow, but maybe it will be something great. So one day I had a chance, and then I was having the right knowledge at the right time, at the right place, and I was lucky. And then I could join some mission to NASA. So try to be ready. Try to gain every day something new. Find out something new. Be interested. Never stop being interested in something. Always ask questions. And if somebody cannot answer, maybe there is a reason. Please find out. That's what I want to say.
Okay, thank you, Professor. Dr. Sean.
Well, as Franz told before, nosiness is one of the motors of development and acquiring know-how. That's what we try to promote, even in sessions like this one. My career is very colorful because I started to study physics. And after one semester, I was nosy to look into medicine, and so I got a permit to study both fields together. And after my basic training, I had the opportunity to have a look into military flight physicians, the job of a doctor who serves for military pilots on supersonic jets. And as it happens sometimes, I met a guy who was doing research on immunology. So I decided to join the program in blood cancer diseases. And so I went to a university hospital where I was trained finally as a neurosurgeon. Later on, 6 years program in pediatric neurosurgery as well. But during my residency, I had the chance to participate with a special permit from the governmental educational ministry to join for 3 months in the Pacific Ocean a American, Japanese, German joint venture on deep sea survey, as well as, for example, looking for manganese nodules. That was between 1976 and 1982. So every 3 months, I flew to the States, Honolulu, San Diego or to South America, to Lima, Peru, to the harbor of Callao, entered the research vessel and did my job in the geophysical survey. What we did there was quite interesting. We had some air gun seismic studies, which were by satellite navigation, were in a big memory system in those days with a lax computing machine. We stored the data, and that's the basis of nowadays know how the sea bottom is structured in the Pacific Ocean. We found out the sea bottom structures between Clarion and Clipperton fracture zones. That is, the mountain chain between Hawaii and California, for example. Or we found south of Big Island, Hawaii, the upcoming hotspot volcano, which reached about 1,500 meters under sea level, but it's still growing. And via earthquakes or tsunamis, it's just moving up, and its base is 6,000 meters deep at the sea bottom. And if you look at Hawaii, Big Island, Hawaii, it has mountains nearly 4,400 in elevation. But the basement is 6,000 meters down at the sea level, so it's more than 10,000 meters in elevation. And it's at least bigger and higher than Mount Everest, because Mount Everest, from the basement up to the top is 8,800 and something meters. Well, my nosiness led me to learn about things. I had no idea in the area where I was born as a pupil, for example, because we had some restrictions. And even my parents were told, my brother and me, you never have a chance to be allowed to go to high school and reach university level. Well, that's what I can say about myself.
Thank you, Dr. Schumann. I'm taking actually thoughts from your last sentence and looking at the audience. I would like to start with the first question, which might sound very standard, but I think it's very important for our audience. And the question is, what made you choose career in science? Was it under somebody's or something's influence on you? And when did that happen? In childhood, teenage years? I think those answers are very important for our young audience.
Should I start?
Yeah,
okay.
please.
Well, so I was born on the countryside, on a farm, 8 children.
Wow.
So my mother had a tough job, my father too. And so I was always hungry for new information. And on the farm we could do many things. So I cut down a tree, I killed a pig, I drove a tractor before I could read and write. And that was possible on the farm. But it was also a bit dangerous. But I always was interested in something new. And And this took me further on these steps and ending me up. Always stay hungry. I think this is the most important information. Always try to find something new. And I think my parents helped me a lot with this. So this morning I had a call with my mom at home, and now she's above 80 and she's not so movable anymore. But when I talk to her on the phone and tell her what I have seen here, what kind of impression, she was very pleased. And she said, I shall tell everyone the best, and good research, and good inspiration for the future. So you see, my mom encouraged me to do something. Also my father did, but my father has passed away already, more than 10 years ago. And it's still nice for me to share all these things with my mom, because I feel like when I find out something new, she should be one of the first persons to know, because she deserves to know, because she did so much for me. I have to give back something to her. That's why I want to give back something to the community, to let you know what I did, so that you can do it better. So the young generation, please try. Do your best.
Thanks, Frank. So we can say to the parents to support their children in their drive to study more science and pursue career in science.
My parents had no money to support me, because 8 kids on a farm, there was no money. So I had to take some jobs to make some money, to get something, and then one day I could buy my first computer. I could write a program, and the computer did what I told him. And this was the feeling suddenly, now somebody is listening to what I say. My words have a value now. Somebody is respecting my opinion and doing exactly what I've said. So this made me feel good. And that's why I said, okay, science is giving me back something immediately. And I felt in literature, when I wrote something, people said, yeah, maybe it's nice, maybe not. But in science, natural science, the law of nature, I ask a question, I do some experiment, I get an answer, and everybody has to respect it, because it will be the same answer for every person in the world, independent of nation, of color, of place, of position. The law of nature is everywhere the same. And this I loved very much.
Dr. Schoner, how did your interest in science emerge?
Well, I was raised in an area in East Germany where Russian mining was the area, and it was totally restricted for traveling in and out, because we needed Russian permission to enter our family's area. And this lasted till 1954. And when my parents learned that for descendants like my brother and me, there is no way to get a better school education, my parents just decided to get into the refugee status. We fled via West Berlin, and ended up at first in a refugee camp, which before it became a German refugee camp, was a concentration camp. And well, this was quite a very suffering and cruel status. Then our family got the opportunity to go to the industrial center of Western Germany. My father got a job, and we lived in a one-room apartment, and we were allowed to use the bathtub only on Fridays. And this was till 59. And in 59, in those days, I entered the school. learned that the only thing to get a better bearable life, like I had as a little child from 46 to the early 50s, in an environment of grandfather, grandmother, uncle, and all relatives, in a quite protective neighborhood. I learned that the only way to get out of this poor, restricted situation is just to learn and try to adapt know-how which can be valid to a further free development. And that's what I did. For example, at school we learned about the Bohr's atomic model. Well, dating back to the 1915, 16, 17s. And I went to a public library, and by fortune I found out about the Schrödinger equation. And we haven't heard that at school, but I was nosy and I wanted to understand what it says, what to do with it. And I was so eager that at my matura status, in Germany we call it Abitur, I was able to present the model and explain it, but the teachers couldn't understand it. Okay, so I decided to at first study in physics. And during the first experimental physics training programs at the University of Marburg with experimental physics by Walscher, I got really some interest in physiological dependencies. And I was just noting I looked in anatomy and the medic training program, and it was so interesting for me that I applied for a double study education. It was quite difficult because the German Physicians Association did not allow to study something else like nature sciences, but next to medicine. Parallel was just impossible. So I had to apply for a special ministerial custodian permit to study these two fields together, and I did. So I have to do that.
Okay. Thank you so much, Dr. Schoner.
I have to add, this is a very rare combination that somebody studies medicine and physics at the same time. It's really very demanding. So Wolfgang is very modest, but combining two different fields like this gives you a much better insight into the things. That's why then you can go deeper into this. So always be open, not just stay to the limitations you are facing. Always think about what comes next. And once you realize where's the border, then you realize how to overcome and discover new things.
Thank you.
So nowadays we have courses and specialties in medicine physics. So you're kind of pathfinder in the field, I suppose. Okay, thanks again. Now I'm handing over the mic to the audience. Questions?
Yeah, couple. So this question is to both of you. There's this saying that the greatest challenge is to know enough about a subject to think that you're right, but not enough to know that you're wrong. So how did you overcome this in your respective fields?
Can you repeat this? I don't want to give you the...
As young scientists,
Yes.
that when you were just beginning your career,
Yes.
have you ever encountered this fear where you know enough about the subject to think that you're right, but not know enough about it to know that you're wrong? And how did you overcome this?
Well,
Kind of professional Demi Kurgan.
yeah,
Probably in the first years.
yeah. So, yeah, it's a difficult question, but you want to answer it?
Of course. Well, in the field of medicine, over the centuries, we have improved medical ability to treat patients suffering from disease. And of course, we learn by mistakes. Without mistakes, we would have a status maybe in the 80s and 90s, earlier. And it is a substantial issue that a single person in a patriarchal academic society can reach know-how and improvement in treatment techniques. But it is evidence for teamwork. And teamwork is the only proper access to safe techniques and to protocols to come around the mistakes, which for the treatment of a patient can sometimes be really frustrating.
So if I may add,
Of course.
the difference to the chemistry is that if one experiment fails, I have another chance. But if a treatment of a patient fails, maybe you have no second chance.
The
For
patient.
the patient.
Scientist, yeah.
The scientist has, but not the patient. But you care about the result. So that's why I always had much respect of the medical experiment, because there is much more at stake. But in the chemistry lab, I can do 10 experiments at the same time, and it is very important that some of them fail and others are positive, because only when you see the difference, you learn. We only have, you see, there is a border here, and I see this border, and along this border, I get new information. If there is nothing, I have no reply, no response, nothing. We only see the surfaces of the things, and this can be in different dimensions. And every information you get, even from a bad experience at the first moment, it will help you. So the best thing is to think about what is the possible result. And then you say, okay, if the result is here, it's positive, it's here, it's negative. And then the negative one is very valuable too, because it helps you to exclude a lot of other things. And sometimes even the negative result is the one you want.
Because it teaches you.
So it's you need both. This is the answer. You need really both to progress. But when you need publications, usually the positive things you can advertise much better than the negative things. I'm sorry, but this is the truth.
My next question is to Dr. Schoner, because this year, well, the end of this year, probably the beginning of next year, our medical university here is restoring for the first time in 30 years the program for astromedicine. I think that's the field. So I'm actually invited as a guest lecturer, but my question is, for those scientists that are going to embark this combination of physics and medicine, what is probably the most valuable advice you got when you began, and what would you advise them?
Well, from experience in space, for a long time, and we learned that there are some really surprising effects, actually. One of those effects is, for example, the increase of intracranial pressure. That means the network pressure, where the pressure inside the hard skull is raising. This is because of the pressure situation in the space environment, which allows us to stay alive and to do normal work, but it's a lower pressure from the outside than we are used on Earth. It's not 1 atmosphere like on Earth, or even more sometimes. And there was a program to how to get results on the effects of that increased pressure. And there are two ways in my specialty. We are used to check the effect by controlling the inlet of the optic nerve into the eye. At that position, we call the papilla. That's the point where the whole nerve reaches the eye and spreads out its nerve fibers to the retina to get the optic information from photon analysis. And the last attempt to measure something which is happening there was from the technicians to introduce on the last space experience programs on ISS, a not so very precise measuring parameter. And so we are suggesting a system where a computer enlarging camera takes movies from the retina, that's the background of the eye, and takes samples of the arterioles. Those are the little vessels, venous or arterial vessels, which react with incoming light or just getting rid of light. So what we did was we developed a system to calculate the diameter of the little arteries, 5 in a row, and then having identified those 5, we got stroboscopic light flashes in the eye, just one side, the other side. And we see on the vessels the reflectory vessel control reaction, which is a micro perfusion measure for brain organs, for blood distribution in the liver or in the kidneys. And those important organs can be exactly mirrored in microperfusion. That means life stages of the organs. And we can then, with those new measures, we can change control and change the environmental system and make it so perfect that those nasty side effects can be prevented in future missions.
Thank you.
That was one of the samples.
Okay, thank you.
Just I add a little thing. Last week, me and Wolfgang, we have met several astronauts, and also the boss of Alexander Gerst and Matthias Maurer, two German astronauts who have been just on the International Space Station, and he also did perform some medical experiments.
Thank you very much.
Raise your hand if you have questions.
I would like to discuss how possible it is that Mars has one time ago stained white, I mean, material, like very simple ones. And the last mission of NASA, the rover Perseverance, its main mission is to find samples. Who will be the people that will examine these samples? And maybe one beautiful day we colonize Mars, will there be a profession like Martian fossil hunters?
What was the last one? Will there be a professional Martian?
Martian fossil hunters, people who
Fossil. Yes.
fossil hunters.
Okay. Yeah. Well, we haven't found any dinosaur bones on the Mars or no fossils yet, but on one meteorite which was coming from the Mars, landing on the Earth, we could trace it back to the Mars. There were some indication of bacteria, but it's not 100% sure if there was some contamination on entering the Earth or something. But right now, as you say, Perseverance is collecting the samples in little titanium tubes, and they will be collected by next rover mission, and then some will return to Earth. And last week, I definitely got the confirmation that I'm officially requested to also investigate these samples. So I'm looking forward to see, because many people should look at these samples with different methods, and these methods are changing by the time. So when we got these more than 380 kilograms moon rocks and soil, back 50 years ago, the last Apollo mission started in December 1972, so really 50 years ago. We just had a celebration at NASA, and there was even Harrison Schmitt, the last living human being, the last astronaut, having his footsteps on the moon. So these samples were investigated, but some of these samples being closed 50 years ago are still closed, not opened yet, because the technical revolution has occurred in many steps. So we have now techniques we can measure at the level of preciseness which was impossible 50 years ago. So therefore we really think it will be even better than that. And basically when the computers are getting better, then the methods getting better, then you find something new and so on. So right now we have several improvements for our little device, which is on Mars, and I think we can do these measurements now much better than before. And we have ideas to even improve it. But of course for this you need time and money, both, mainly. But yes, we need a good idea. And and then you can try. You see, Elon Musk has a lot of money, so he pays a lot of good scientists, and they come up with a lot of nice results. But he also is bringing the things together and having his own playground, has achieved something which other people could not, because with public money I have to write tons of paper before I get a little pile of money for doing some research. This is a problem. But Elon Musk has made some business, and like business has a pile of money, and he's doing it's a bit easier. So let's see what we can do.
So life in space. You can just add a little that. So as far as men are entering space with ships, with whatever, and are setting foot to one of the surrounding moons or planets or asteroids, no matter what, they are leaving something that has to do with life. And the best example is, do you think on Moon you could find some life? Probably yes, because one of the astronauts on his mission dropped a plastic bag containing pictures of his family. And it's still there. And who knows what is on the picture? Or
I have to say, they not only just draw pictures of their family, also other things.
yeah.
With biological content.
One last question. From that point from which we stand here today, how close do you think our scientists are into adapting and understanding Mars's soil to a point where future colonizing astronauts can actually maintain crops? How close are we to this reality of maintaining crops and having a substantial living on Mars?
Yes, there are some problems. And having a lot of money helps to solve some of these problems. But some of these problems cannot be solved with money. You need also some new advances, some new developments. So, for instance, irradiation is there. And the astronauts flying to the Mars for 7 months minimum will consume a lot of radiation. And usually one astronaut on the space station is consuming around about 200 millisievert irradiation every year, because they fly through, the outer sphere of the magnetic field, so they get more irradiation. Just when you take an airplane, you also get more radiation than staying on the surface of the Earth. And we are trained to have some radiation. We are actually eating food which contains some radiation. Every second, in an average 70 kilogram person, guess how many nuclear decay reactions occur every second? How many events? And the units for these events is becquerel. 1 becquerel is 1 event in a second. What do you think? A 70 kilogram average person, how many of these events do we have? How many becquerel do you expect to have from you or me? Anybody has an idea? How many?
1,000.
Million.
You say 1,000?
Billion.
How long?
Well, 10,000. Okay, 10,000. But imagine we would have a sensor for nuclear decay. Then every second we would have 10,000 times. Well, that would be really shaky. Maybe this is the reason why we don't have a sensor for this. Why we cannot feel the nuclear decay reactions. But they are there, they are going on, so we're living with it. So it's part of our life. So we have to get used to these things. But so going to the Mars, you get a lot of these events. 200 millisieverts is the astronaut. What is it? What is the average dose? For an average citizen, you have 4 millisievert. 2 of them you consume by nature. 2 by flying with aeroplanes or getting medical, X-ray, and things like this.
Mars, you consider more.
Maybe if you live in some special places, higher up in the mountains, you consume more than down there close to the river. There's a difference of like 10 times or more. If you live in Ramsar, Iran, then you get 300. It's one of the most high spots, local spots of radioactivity in a city worldwide. Of course, so you see there are differences. So we have to protect the astronauts with shielding, but this shielding takes energy. This energy takes mass. So we think about new sources of energy, how to protect these things. And then once you live on Mars, you need to protect. You need to create such shielding things. So the first thing to go there is use some other robots to build up an infrastructure before the humans come in. That's why we selected on the moon the spot where we have little irradiation, where the sun is not hitting the astronauts, where they are hiding, like in a kind of like a cave, where no sun is going. It's rather cold there, but also radiation is low. So these are the ideas, but we still have to work on it.
I have a question to the audience. Who owns a X-ray radiation passport?
The X-ray?
It has to be issued internationally conventional reading. That if you get an X-ray from your thorax, the
Yes.
lungs, the doses have to be written into a X-ray passport, which must be available for every patient.
Sorry.
You heard of it? Well, next time you see your doctor and he wants to check on a broken leg or something else, ask for a passport because it's first free and it helps to calculate a limited range of X-ray exposure, which is helpful, especially if you one day want to go into
Yes.
Do you agree?
Yes, I have one, but I'm checked, like when I go to the lab and we play with some radioactive sources by nature. So I need to see how much I have consumed, just to be safe, you know. But, you know, we should be worried too much about it when we keep everything in some safe restrictions. But you should not, you know, you should always be aware. Protect yourself as much as possible. Keep distance.
Except to live in Yakimov or in Snowbird.
Yeah. Or don't dig holes in Chernobyl, you know, and hide yourself in the soil. Just because somebody told you to. I don't think this was a really good idea to do so. Poor people. We still have wild pigs in Germany who have some Chernobyl radiation we measure every year. And but these pigs, they like the mushroom very much. So they can even eat the mushrooms from down there, which have still some more radioactivity from nuclear bomb testing. So the pigs still enjoy the mushrooms, but yeah, we should think about all kinds of things. So,
yeah, I know you're biased about Mars and going to Mars and colonizing or terraforming Mars. But my question is more in the sense, I want to put yourself outside of this bubble and try to think, not to be biased. Do you think which is more important, to reach Mars or to try to keep our planet a better place to live? And instead of going to Mars, maybe work on asteroid mining, which is still a space mission. Which one do you think is more important?
Both.
As a step?
both.
Both.
I think we have the capacities to do both. We can work on both, and we had some. You know, I'm also a member of a mission which is called Asteroid Redirect Mission, and the idea is to take an asteroid. And actually Trump stopped it, well, thanks to Trump. And then we had the DART mission, which was like a precursor mission, so to see whether you can deviate the trajectory of such an asteroid. And the idea is to bring this asteroid to the moon and make him a a moon of the moon or a satellite of the moon, and then do some mining there. So you have both.
We're putting too much effort to go to Mars.
I think, you know, see, when we're landing on the moon, I've seen the plans of
Technically.
Jesko from Puttkamer and Werner von Braun. Everything was ready to go to the Mars after the moon. So they had all these steps, and even the space shuttle. They had the space shuttle already, model of it, and so on. So they were ready to do this, but just the money was not there anymore, because they have shown that we can do it. And there was this Sputnik shock before, so, oh Jesus, the Russians are so much smarter than we, so we have to do something. But then they thought, oh, now we're good enough, we don't need to go to the Mars anymore. They could have done it already in the past, putting more money in, but they decided not to do. Now we have a chance. Of course, you're absolutely right, we should keep our world a good place. We should save the world. But we are not just one human being. We are more than one. So if we can make the money, then we can follow any steps. In biology, distribution is important, and the broader it is, the more things we can do.
And maybe the only point to go to Mars is to make a base camp to be near to us.
We have learned a lot from the Mars not to do on the Earth. So from these discoveries, I believe it's worth that I think we can make we can save the Earth and keep it a good place for living for a much longer time, because we've seen how things can go wrong on the Mars in a natural way without human influence.
Well,
And we should
I think
take over that.
to make a colony out in the Mars area is just nonsense. But it's a good place for robots as a gateway to reach other more humanizable areas in the future. But at first, we have to take care of getting our Earth to a status where, in the long run, our children can really survive. And we should not pollute it.
That was my point.
Yeah.
But for instance, starting from the moon to the Mars is 10 times easier than from Earth. So why not to do? This is one of the things. We need 10 times less fuel from starting from the moon than from Earth. Why not? But you're absolutely right. The Mars is dangerous for humans. And right now, with the technology it's a question whether people can really survive this trip to the Mars and back.
What we learned,
But thank you very much.
yeah, what we learned from, well, political decisions, for example, to mine uranium in the Iron Mountains of Germany. We learned that in a whole community, the events of lung cancer moved up extremely. And it was discovered at the East German University Hospital of Berlin, at the Charity Hospital. And the disease is called internationally the Snowbird lung cancer. And it was caused just in the area of uranium mining because radon just went up in the soil, entered the home, and caused a radiation affected lung change in the cells and got a genetic induction of cancer. And that was just because somebody wanted to sell or give away some precious ores. And by the way, till 1968, it was by law forbidden to talk about it. The charity was prohibited to give an international publication about that substance.
Radon is a decaying product of the uranium thorium, and this radon is actually the biggest natural radioactive contribution to our 4 millisieverts. And as people found out more recently, because now we have more spots in Europe to measure these things, the concentration of is really higher than we expected. So there is now discussion whether to raise these levels and make a limitation for it. And this is a big discussion, because then some cities so they had once a limit, and with this limit half of Germany would have been radioactive contaminated with radon, but then it doesn't make people feel good, and they're still living there for the period of longest period of their life. So what to do? So you see that is also politics. So what you can come up with, but
By the way, radon is being used to pseudo-treat rheumatoid arthritis. There are some
yeah. So in some cases, when radioactivity was discovered, more than 100 years ago, more than 120 years ago, then it was used for many things, like used in you're brushing your teeth with radioactive compounds, so they are more shiny.
Well,
We don't do this.
the Nicholas Real, the physicist, who was participating in the Russian development of the atomic bombs, he was
He was a German.
responsible German engineer next to Sachsenhausen concentration camp of a fabric producing toothpaste with radium for better radiation from teeth.
Shining bright teeth.
Yeah. But the main aspect was for the Nazis. They had radium phosphate to make watches in the submarine in the Toll Bar inevitable. And that was.
We have time for 2 or 3 more questions. So,
I want to ask if we send to Moon and Mars some kind of rover and try to check what time they will stay open on Moon and Mars. From your side, the times, how much will be given?
Could you understand?
How long?
If we send a rover of the same type, Mars and Moon, and we want to understand what time they will be operative, and they will work from the both of the planet.
The same rover,
Yes.
one on the Mars, one on the Moon,
Yes.
and which one will last longer? Yeah.
We know which will last longer, but what will be
The difference?
Yes.
Oh, okay, the difference. There are big differences actually between Mars and Moon. So the Mars,
Atmosphere.
really the conditions
soil
are much
temperature.
different. On the Mars you had a history of water, so all the rocks are a little bit, polished. This is not the case on the Moon. The Moon you never had that. So on the Moon you have really lots of cliffs, so you can easily die on the Moon. So it's much easier to die on the Moon than on the Mars. Yeah, because our rover, it was crashing on the Mars into a crater. Well, actually, nobody's listening from NASA, I hope. And on the Moon, on the Mars, we were, after 90 days, our budget was finished, And if you have no money, you cannot keep your mission up. So we were
kidding.
ordered to drive the rover into some crater. To finish the rover, make a Hollywood scenario finishing, like a Rooney. So the rover could die in this, in a nice way, and then you don't spend any money anymore for this mission, and then you can use the money for the next mission. And the reason why we could survive these 90 days and stay for more than 5,000 days was that the space shuttles had problems. Because of these problems, NASA had to shift more than 2 billion of budget research funding from research to the SLS program, the Space Shuttle After program. And then there were lack of money for the research program, and the next mission were on hold because no money. So they said, but we need something for the public, we need something for the press, we need something, we have the rover. They don't cost us anything because they are working on the Mars. Keep the rover going, it's just little money. Give them some money and we can continue this. And we said, of course we are ready, but now we are half in the crater already and try to drive out of the crater. We could drive out, fortunately. So we survived driving out of this crater. But on the Mars, this was possible. On the Moon, that would have been the finish. I think the final thing, and the gravity on the Mars is much higher than on the Moon because the diameter is even smaller than this.
Atmosphere.
And the temperatures between day and night on the Mars, you have 150 degrees only between day and night. It's like when you go in the Sahara, you have no clouds. The clouds are preserving the heat. So in the day in the Sahara, you can die at 50 degrees heat. By a heat stroke, and you freeze to death in the night because it's cooling down so much that you freeze. And so, and the same happens on the Mars. So it heats up to temperatures which is like on Earth, but it cools down a lot, which is very good for our measurements because we need a nice temperature change. But on the Moon, this is very different. A day on the Mars takes 24 hours and 40 minutes. Anybody got an idea how long is a Moon day? A Moon day takes 14 Earth days. 14 Earth days of sunshine. Can you imagine? 14 days straight sunshine. You get temperatures up to 300, 400 degrees. That is not very helpful. That is not very healthy. You die. You die. You die. You die of these high temperatures. You can imagine. But in the night, you have 14 Earth days of night. So you freeze. You freeze. So you see, the Moon is really different, and so we need to collect a lot of energy and energy storage and so on. So for the Moon station, we have planned some big hydrogen tank to supply with hydrogen these stations, some energy supply, and so there are some other ideas which you could use, like the Perseverance rover, for instance. While we had with our rovers, we had solar panels. So the Perseverance rover is like the size of a Volkswagen Beetle. So the solar power would not be enough. The solar panels producing energy. So they have some plutonium battery decay producing electricity. This one works for 1,000 years of energy supply. But it has some other effects which you don't like so much. But still, the energy is there for a long time. And still you have some devices on the Moon, from the landing of the Moon, from the Apollo missions which still have power after 50 years, which is not possible with chemical energy storage, but nuclear decay is possible. So there are, you see, there are many chances, and so there are big differences. And yeah, so we have to be careful in both ways.
And this will be the last question because
okay.
we are 15 minutes over.
Let's finish with something about the future. What excites you about the future of science, like in your respective fields, of course, something that you're curious about, how things are going to develop? What is that subject, like, that you're really, really curious about? How it's going to turn out in 5, 10, 15 years in the future?
Oh,
Very near future.
this is a very difficult question because my problem is that there are too many things I'm interested in. And the point is, you don't know in which field you will make the next big progress. So I can tell you we are working actually on some nice compact hydrogen storage system, which already ESA told us they would love to use it, because ours seems to be better than the one they have right now scheduled. And if this one works very well, I believe everyone here wants to have this kind of storage next to his house. And because this kind of storage can supply your house with energy for the whole year, giving you heat and electricity for the whole year. In the summer you have solar panels on your roof and they produce the hydrogen, store it there, and then you can use it in the winter and you don't need some other supply anymore, and you don't have to waste any money for this other thing. So I think many people will be interested in this kind of storage, especially if they are in comparison to, for instance, some lithium-ion batteries, at least 10 times smaller. So we were thinking about some cars like that. And these cars, we compared, there's a new BMW electric car, but you know now these electric cars, they are like 2,000, 3,000 kilograms heavy because of the lithium-ion battery. So we exchange our hydrogen storage, and then instead of a few hundred kilograms, they can drive a few thousand kilometers. And they will be much lighter, and they will be, yeah. So this is a dream which I really want to come true, and then having this storage even on the moon would be a real nice thing. I'm believing in, so we tried, and actually I'm not allowed as a university professor to make such a company because there are some rules, and these rules restrict you to do many things. But two of my cousins are allowed, so they founded a company in Austria. So they are very bright. They're working on this, and they have made quite some progress, and I hope that they can manage. I just got in today's newspaper in Austria, they had an article in and they could win as the best startup of the year some prize already. So they are doing well, and I hope this will continue this way. And then I hope we can manage this. And if we can do this, then maybe this storage can also give us the money to pay for our space missions. And then I don't need to apply so much anymore for these other things. I'm wasting so much time